Myself Dhanyashri Bibi. Our topic is IPL T20 database system. I was presenting introduction. The IPL T20 database system is designed to manage and organize comprehensive data associated with Indian Premier League IPL, one of the most prominent and commercial successful T20 cricket tournaments in the world, with hundreds of players, a dynamic action mechanism, and a globally followed season based format. The IPL generates vast and complex data every year. Efficiently managing this data requires a well designed database system. This assignment focuses on building both the conceptual schema and logical schema to represent the IPL ecosystem. The database will capture critical elements such as teams, players, actions, matches, and stadiums, along with their attributes and inter interrelationships. It will also address real world complexities such as player transfers, seasonal participates, and venue scheduling. Next, continue by Lasya.
Hello everyone, this is Lasya Pishetty and I am presenting the ER diagram in this presentation. Here we are having the IPL T20 database system ER diagram and the entities like the player, performance, match, stadium, team, and auction purchase. And each entity having the attribute like for player we are having date of birth, nationality, role, name and player ID. Player ID acts as a primary key for player attribute. Player ID as an attribute acts as a primary key for player entity. And for performance entity, we are having a player ID, match ID, runs scored, wicket taken, and catches. So performance entity having a player ID foreign key from their table and match ID as a foreign key from the match table and runs scored by the player, wickets taken by the bowler, and catches taken by the player. And match entity having the attributes like match ID, date, team ID, team 2 ID, stadium ID, and winner team ID. Stadium ID acts as a foreign key from the stadium entity, and the match ID will also act as a primary key for match entity. And team 1 ID and team 2 ID will be from the team entity. And nextly, the stadium entity has attributes like name, location, stadium ID, and capacity. Stadium ID is primary key for the stadium. Is a unique value, means all the stadium will have a unique value as a stadium ID. And T entity having like home stadium ID, owner, name, team ID, and coach. Team ID acts as a primary key for team entity. And auction purchase having a attributes like price, player ID, auction ID, and team ID. So here team ID is taken as a foreign key from the team table, and the auction ID is also a foreign key from the auction table, and player ID and price means the player at which price the player is taken to the team. And then auction is having the attributes like auction date, the date which has taken place, and the auction ID is a primary key, and a season year in which season the auction is taking place. Then we are having a relationship like participates, like player performance, like in a team. Then the performance will be done by the player in a particular match, and the match will be held at the stadium. So we have taken a relationship like held at, and the team will be having so the players will be belongs to the team. So this is about the ER diagram. Nextly, we are into the relational schema. So firstly, for the player, the table name like player ID, name, nationality, role, and date of birth. Player ID is a primary key for player table, and team having the attributes like team ID, name, owner, coach, and home stadium. These are all the column names. So the team will have a primary key called team ID, and a team name, team owner, team coach, and the home stadium of that team. And next table is stadium. The stadium having a primary key, stadium name, stadium location, and the stadium capacity. Nextly, the match table having a columns like match ID, which is a primary key, and a match date, stadium ID, which acts as a foreign key from the stadium table, and team 1 ID, team 2 ID, which both will act as a foreign key from the team table, and winner team ID. And auction having a table, and the column names are like auction ID, which acts as a primary season year and the auction date, and auction price having a foreign key as auction ID from the auction table, and the player ID is also a foreign key from the player, and team ID is also a foreign key from the team table, and the price at which the auction has been taken place. And next table is about the performance of a player. So in which match player has performed is a match ID and a player ID, and the run scored is also given as a column name, and wickets taken by the bowler, and the catches that are taken by the player in the team. Next will be continued by Madhura.
I am Madhura. I am presenting DDL statements and SQL queries. Player table contains details of cricket players. Player ID uniquely identifies each player. Name, nationality, and role gives personal and role information. Date stores the date of birth. Uh, team table. Table holds the information about cricket teams. Each team has an ID, name, owner, and coach. Home stadium ID connects to the stadium table using a foreign key, establishing a relationship between a team and its home stadium. Stadium table. These both stadiums. Stadium ID is a unique identifier. The name, location, and capacity describes where, how big the stadium is. Match table. This table records the match details. It includes the data and IDs of two competing teams, the winner team, and where the match was held. The foreign keys ensure all the IDs must exist in their respective tables. Auction table. This table stores the details of auction events, including the year and date of the auction. Auction purchase. Auction purchase table. This is a bridge table that tracks which player was bought in which auction by which team at what price. It has the composite primary key and on auction ID and player ID to ensure each player can be bought only once per auction. Performance table. This table records a player's performance in every match. It uses a composite primary key, match ID, player ID to uniquely identify each player's performance in a specific match. Next, the data is the sample data is inserted into the tables. SQL queries. Um, this is the basic queries to show all the players in the player table. Here it shows all the players in the player table. Um, Select name coach from team. This query shows the team along with the coach in the team table. This nested query finds all the matches that took place at the Wankhede Stadium by first identifying its stadium ID. This query gives the list of player IDs of all players who scored more than 50 runs in any match based on the performance table. This nested query returns names of the players who were purchased in the 2023 auction. It joins the data from the purchase, and the player performs a team name and their home stadium, performs join between the team and stadium tables to show the team name along with its home stadium name. This query shows about match IDs along with the winning team's name using join between match and team. This query displays all the names and playing roles. Example: batsman, bowler. Next will be continued by Kavana.
Myself, Kavana, I will be concluding the about IPL database system. This IPL database system effectively models the major components of the Indian Premier League, including players, teams, matches, auctions, and stadiums. The year diagram lays out a solid foundation for understanding relationships, while the relational schema translates these concepts into a practical, implementable design. The system supports complex queries like tracking player transfers, performance stats, team compositions, and match outcomes. This structured approach ensures data consistency, scalability, and efficient retrieval for future IPL analytics or management tools. Thank you, one and all.